for Newton's laws of motion, past paper questions. This is the last question. So read the question first. Given that both planes are smooth, find the acceleration of A and tension in the string. So if the planes are smooth, we don't care about the mass here because there is no friction. So the force in this direction, horizontal, there is none. And for the B, the force in this down the slope is the W sine. The mass is 2.4. We can find the weight, which is 24, and the angle is 30 degrees. So 24 sine 30 degrees would be 12 newtons. This is the weight component down the slope. So for the FBD of all objects, we have only one force in this direction here. We ignore the rest because they are not irrelevant. So we have 12 equals the mass of the total, which is 1.6 and 2.4 kg, times acceleration. We can find the acceleration, which is 3 meters per second squared. And for the tension, we can just use the FBD of object A here. We have the tension to the right is equal to the mass 1.6 times the acceleration, so 4.8 is the tension, or you can use this FBD, you'll get the same tension. It is given that the horizontal plane is rough, coefficient of friction, inclined plane is smooth, total distance traveled by A, 9 marks. So first of all, we have weight 16 newtons downwards, the normal reaction 16 also because horizontal, and the weight force is 0.2 times 16, which is 3.2 newtons. And here we use the FBD of all again, but this time we have the force which is opposing the acceleration, so the 3.2 is negative and this 12 is positive. Total mass again 4, we get the acceleration. So after this object B is moving 1 meter down the slope, that means object A is also moving 1 meter to the right because the string is inextensible, same distance traveled. So after traveling for 1 meter, we use SUFAT V squared equals U squared plus 2AS. The U is 0, so this is just the square root of 2AS. The A is 2.2, the S is 1. We get the velocity here after traveling 1 meter. And now we have this new FBD because the string is no longer pulling object A to the right here. So here we have only friction to the left. There is no tension force. We still have the weight and the normal reaction, and the acceleration is to the left. It's trying to slow down the object here. So using sigma f equals ma, we have only 3.2, the mass is 1.6, we get the acceleration or deceleration actually. So now we use the initial velocity is this square root of 4.4, the final velocity is 0 when it stops, and the acceleration is -2. We have v squared equals u squared plus 2as. You can find the s. So this is the distance traveled by this object until it stops, and the total distance from the beginning would be +1. So this is the total distance traveled. Next question. Read the question. Show that before the string breaks, the magnitude of the acceleration of each particle is 3. So we have weight, tension, sigma f equals ma. For all the bodies, we have 13 going down, 17, the 7 newtons going up. So 13 minus 7 equals the total mass. 1.3 plus 0.7 is 2. We have the acceleration, so it's shown. Find the tension in the string. Here we are using the FBD of A. 13 downwards positive, the T upwards negative. 13 minus T equals the mass is 1.3 only. The acceleration we already know 3, so we have the tension. Find the difference in the times that it takes the particles to hit the ground. 6 marks. So when the particles are at the same height, the string breaks. So at the same height means after object A is going down 0.375 meters and object B going up 0.375 meters, of course. So this means the height above the ground when the string breaks is 1.375. So this is when the string breaks, and we can find the initial acceleration here. Because of this acceleration, which is 3, traveling down 0.375 meters, we can find the final velocity. So initially 0, after it is accelerated this distance with this acceleration, we have the initial velocity. So this is now the velocity right when the string breaks. So A is going down, B is going up. And now to find the time to reach the ground, well, we have the distance going down. Let's say going down is negative, so negative 1 point, this is S, this is the U, negative going down, plus 1/2 the A, minus 10 because going down, minus, we have the time for A to reach the ground. And we do the same thing for B, but this time the initial velocity is positive, and we get this time. The question is to find the difference. We subtract, we get exactly 0.3. Actually, it is exact value if you just use algebra first. Right, read the question. Find the acceleration of Q before it reaches the floor, and hence find the value of H. So here we have 5, 3. As usual, 5 minus 3 equals total mass 0.8 times A. We get the A. And to find the distance H, here we have 0.6 seconds. So here we are using S equals ut plus 1/2 AT squared, but the U is 0, so this is just 1/2 AT squared. We get the distance traveled here to reach the ground. And find the velocity of P at the instant Q reaches the floor. So after the same amount of time, 0.6, the P will be up here, around here, and it's still moving upwards 1.5 meters per second. And total time taken from the instant at which Q is released until the string becomes taut again. Becomes taut again means, so the P will go up and the Q will reach the ground, and the P, because it still has this 1.5 meters per second, it will still go up. So it will still go up to maximum height, and then it will go down again. When it goes down again, so from this height go up back to this height again. So when it's back at this height again, this thing is taut. So the displacement from the moment Q touches the floor, the displacement is, you go up, you go back down to the same height, so the displacement is 0. Initial velocity, let's say positive upwards, so the 10 is minus. We can find the time, 0.3. So the total time would be 0.6 plus 0.3, 0.9. Right, that's it. I'll see you guys.